Myself, along with my teammates Ben, Sydney, and Stefan, are all in electrical engineering, and we created a low-tech electrocardiograph device. Electrocardiograph machines sense the electrical activity of the heart using electrodes that are placed on the patient. ECG machines can be used to detect ischemic heart disease, stroke, heart defects, and other structural abnormalities, along with many other ailments. Ischemic heart disease is the leading cause of death worldwide, 80% of which occurs in low and middle income countries. 70% of strokes worldwide occur in these countries as well. These high mortality rates can be attributed to barriers in healthcare where patients frequently present in critical stages of heart disease due to lack of diagnostic devices in many areas of developing countries. We know that there is a serious lack of medical equipment available in low and middle income countries. These countries rely heavily on donations and remanufactured medical devices. About 40% of these devices are out of service in developing countries. The devices they receive often break after a short period of time, and these countries do not have the funds or technical knowledge to repair them. This led us to the conclusion that a device is needed that can perform an ECG to North American medical standards using a low-tech design with a material cost of less than $100 that can be easily repaired and work seamlessly with the computers and power supply that is available in developing countries. We designed a 3-lead electrocardiograph machine that has a material cost of $84.36. This cost is based on buying components for a single implementation of our design and will reduce significantly when purchasing materials for the mass production of our device. To put the cost in perspective, a low-grade ECG machine costs about $1,000, with machines used in hospitals costing upward of $6,000. To further support why a low-cost ECG device is needed in low and middle-income countries, we can look at the average amount of money different countries spend on healthcare per person each year. For example, Morocco, which is a middle-income country, spends $175 per person annually on healthcare. Contrast this with the $7,064 the Canadian government spends per person every year, and we can clearly see why the design and implementation of lower-cost diagnostic devices is essential to increasing the quality of healthcare in developing countries. Let's go back to Morocco for a second. The top 3 leading causes of death in this country are ischemic heart disease, stroke, and hypertensive heart disease, all of which can be diagnosed with an electrocardiograph. If we step further back and take a look at how this low-tech, low-cost electrocardiograph could benefit the world, let's try to grasp how many people are in need of a technology like this. In 2019, there were 7.674 billion people on the planet. 6.437 billion of these people lived in low and middle income countries. That's almost 84% of the world population that is living in developing countries. Since we know that ischemic heart disease is the leading cause of death in the world at 16%, with stroke a close second at 11%, it's easy to see that an ECG machine is a necessary diagnostic tool in the healthcare system. Ischemic heart disease and stroke are the top 2 killers of people in middle-income countries and the 3rd and 4th leading causes of mortality in low-income countries. Yet, these countries do not have access to affordable and reliable ECG machines that are compatible with reusable electrodes. Here's a demonstration of our device running a 3-lead ECG on one of our group members. Lead 1 is shown in red and is the difference in electrical activity between the left arm and the right arm. Lead 2 is taken between the left leg and right arm and shown in green, and lead 3 is the left leg and left arm shown in yellow. The second clip is focused on lead 1 of the ECG, and the table below it breaks down the major components of a cardiac cycle. As you can see from the data, our device performs well and produces an output that is consistent with the clinical expectation for a healthy person. The P wave is the first little bump before the spike. The QRS complex is the spike itself, which is the point where your ventricles contract. And the T wave is the final deflection of the heartbeat, which is seen as the last burst of activity before the next heartbeat. On average, medical devices take 3 to 7 years to become fully licensed and ready for market sale. ECG machines are considered a Class 2 device out of 4 possible classes, so they will take less time and cost less money to be licensed for market sale than most other diagnostic medical tools. We are confident that future work during the licensing process will result in a fully functional, low-cost, low-tech electrocardiograph. Thank you for your attention, and we look forward to answering any questions you may have.